We're back at it for lesson number 13. Getting up there in the lessons, and today we're going to be simplifying radicals. I'm coming at you still from my mom's house. You can tell by the sweet wood paneling and the tight decorations behind me there. Lots of cool stuff around here. And if you got to chance to stop in for the Zoom meeting today, it was pretty sweet because the car I was in broke down on my way to get back for the meeting, and so I did a virtual Zoom via cell phone in a broke down car. It's pretty sweet. Probably the coolest Zoom location that any teacher's done so far. I don't know. I haven't heard all the other Zoom locations, but I imagine it's the coolest. So today we're going to jump into it. Simplifying radicals, a little left turn from functions. You'll see this a lot in geometry, especially when you're dealing with things like where you would see square roots with like distance formula, which we know is the Pythagorean theorem. And I just want you to make sure you finish strong. If you finish something that I've already graded, make sure you email me. You have a question, you hit up those office hours. They'll be again next week, Wednesday, 3:30. And I've been getting back at emails. Sometimes I have to wait a day or two, just depending on schedule, but I promise you I'll get back to them. And then, all updates for everybody I've been putting on Classroom. So I did have a little update from the last lesson that I put up to Google Classroom, and maybe you saw it through your notifications. But I continue to hope you're all doing really well, and I hope you know I wish I was there with you in person handling all this cool stuff, and I look forward to next year when we can hopefully high-five and junk again. So let's get into this lesson. Simplifying radicals with Mr. Mac. Okay. So a radical is just a square root, and you guys have seen me do this before. I showed you this on some stuff when we did like distance formula and stuff to give you some exposure. But really what we want to do, the goal, is to find factors that are perfect squares. Okay, so we're looking for perfect squares. So if you don't know what are perfect squares, that would be things like 4, 9, 16, 25, 36, 49, ... So anything times itself gets us there. And the reason we're looking for perfect squares is we can take the square root of all these numbers and just get a number. All right, so that's why we want perfect squares. So you might notice 28 is not a perfect square. No whole number times itself equals 28. So you need to start thinking, what number from this list might be a factor of 28? And so I'm hoping in your head, you're popping off factors of 28. 1, 28, 2, 14. So far, nothing. 4, 7. Oh, baby. Number 4. So, this is an intermediate step I would encourage you to do, but you would not have to do if you really felt confident. But understanding that the square root of 28 is the same thing as the square root of 4 times 7. And the reason why that 4 is key is because I can take this 4 and I can do the square root of that 4 and bring it out. So the square root of 4 is 2. So instead of having a 4 under the square root, I can have a 2 on the outside of square root. And this would be called 2 square roots of 7. Now, one way to check this is to make sure the value of square root of 28 is equal to the value of 2 square roots of 7. So important, when I say this word simplify, we haven't changed what it is. We're just changing how it looks. Okay? So these are the same thing. This down here is just the simplified version, 2 square roots of 7. Guys, it was the first one. If you don't get it, hang tight. We're going to do more. Again, I always say it. Rewind, rewatch, send it to your grandma, all right? Whatever you need to do with this video to be successful, make sure you handle it. So let's look at this. We've got square root of 48. And again, we're looking for those perfect squares. So a factor of 4, 9, 16, 25, 36, ... Something in that sequence, right? It's not actually a sequence, but something in that list, okay? So as I'm thinking about factors of 48, I got 1, 48, 2, 24. Nothing's hitting me right now. 3, 16. Ooh, 16 looks nice. All right, so I can think of square root of 48 as a square root of 3 times 16. And the reason that's useful is I can take the square root of 16. Look at, see ya, buddy. You get to go free. Live out here, okay? Square root of 16 is 4. I can rewrite it as 4 outside of the square root. And the answer to this simplified would be 4 square roots of 3. Now, let's say you think you screwed up. And you thought of 48 as a square root of 4 times 12. That's cool. You're like, okay, I'll take this 4 outside here. Come on, 4, get out there. And I got 2 square roots of 12. That's okay. This is not the answer because 12 also has a factor of 4. So you could use that as an intermediate step. Break your 12 down to a 4 times 3. Bring that out as a 2. And that would give you 4 square roots of 3 because that 2 times the 2 is the 4. So, you know, when you're done, look inside here and make sure you don't have any factors that are perfect squares. So like 3, no other perfect squares. 12, that still has a perfect square as a factor, so you need to get rid of it, okay? We need to simplify it more. Let's look at 49. Oh, this one's nice. Boom, done. 7 times 7 is 49, no square root at all, all right? So if you see something like that on your homework, don't let it trip you up, all right? It's just 7. Or if you're thinking quadratics, technically, it's plus or minus 7, but the work's going to be looking for that one right there. Number 4, we got a 27. So I got a 127, I got a 3, 9. Ooh, that 9 looks nice. So 27 is the same thing as the square root of 3 times 9. I can take the square root of 9 and send it out front there. Square root of 9 is 3. That gives me 3 square roots of 3. Again, check it. Use your calculator. Make sure the value of that is the same as the value of that. It'll work if you did it right. It's the same value. Number 5. Ooh, this one looks a little tricky. That's a big number, 256. So one thing that you can do to make life kind of nice on you, this is a little trick. Don't let everybody know I'm giving you this little trick, but I like to do some prime factorization. So I got a 2 and 1, 28. I got a 2 and 64. I got a 2 and 32. I got a 2 and an 8. Lots of 2. No, not an 8. Don't do 8. 2 and 16, 2 and 8, 2 and 4, 2 and 2. Dang. So I got all these factors of 2. But here's what's cool. So you can look and be like, well, here's a factor of 4. All right. So 4 is a perfect square. I could use that. But guess what? What's 4 and 4? 16. It's 16. So right here I got a factor of 16. And check it out. 4 2's down here as well. 16 times 16 is 256. So guess what the square root of 256 is? 16. And the better way to do that, instead of just punching a bunch of junk in your calculator and seeing if you get there, I just broke the number down using prime factorization so I could look at the factors a little easier. So that's a little trick for you if you want to use it. All right, let's get back to one a little more traditional to what your homework's going to look like. We got 32. And you know what? Let's do that prime factorization again. It's a good skill you learned earlier in your life, okay? So as I'm looking through here, I've got a 4 and a 4, which is a 16 and a 2. So factor of 16 would be nice because I can take the square root of that factor of 16 and get 4. So if you're having a hard time just seeing one of those perfect squares as a factor in your radical, go right here. Plus, doing prime factorization is kind of fun. A little extra there too. I always see a hockey stick right here. Anybody else see that when you do your prime factorization? Like a hockey stick. That's what I see. Anyway, one more for us, all right, before we hit the road. Before you get practicing on formative. This one should pop. One of my favorite square roots for some reason is of 25. I love the factor 25. It's probably because I like working with hundreds. And so I'm hoping you see a 25 times 3 there. The square root of 25 is 5. And that's going to give me 5 square roots of 3. Remember, you can check it by just slapping those in your calculator. And the answer will be the same. Now, it's going to be an irrational answer, right? You could have some ugly decimal, okay? But it is going to be the same both, so that's always a great check in your calculator. All right, keep working hard. Email me with anything you need.